All right, question 2 here. The position of a particle is given by, this is a function of t equals 2 over t squared plus 3t minus 1 all cubed. We want to find the initial velocity and acceleration of the function. So we know right away that if we're going to find velocity and acceleration, we're going to need to find the first and the second derivatives of this function. So let's get our velocity function first, which is going to be our first derivative of our position function here. So we can rewrite this position function as 2 times t squared plus 3t minus 1 all cubed, and then use the chain rule to do my, sorry, not cubed, change that to the negative 3 there, and then use our chain rule to do the derivative here. So I bring down the negative 3 times 2 gives us negative 6. We keep the stuff that is inside the brackets here the same, and subtract 1 from our exponent. And then we multiply by the derivative of what is inside the brackets, our inner function. So that's going to be 2t plus 3. If I'm asked for the initial velocity, okay, initial just means when time equals 0. So I want to evaluate v at 0. So I sub in 0 everywhere, and I see a t, and I get negative 6. Let's see, 0, 0, so negative 1 to the negative 4 times 0 plus 3 is just 3. Now what about this term here, negative 1 to the power of negative 4? Well, I can rewrite that, if we work over here at the side, negative 1 to the negative 4, change that negative exponent into a positive exponent by moving it down into the denominator. This is negative 1 to the power of 4. It's an even power, so this is going to be just 1 over 1, or 1. So simplifying this, I have negative 6 times 1 times 3, so that'll give me negative 18 meters per second. Now that we've taken care of our velocity, we can move on to acceleration here. This is going to be s double primed at t, or the derivative of our velocity function. So we look at our velocity function up here, and we see that we've got negative 6t squared plus 3t minus 1 all to the negative 4 times 2t plus 3. Because we have this multiplication sign in the middle here, and we've got a function of x over here and a function of x over here, we are going to have to use our product rule to do this derivative. So our derivative is going to be, let's see, we'll do the derivative of the first half there. So negative 4 times negative 6 is going to give us 24. I'm just using the chain rule here to the negative 5 times the derivative of what is inside those brackets there, 2t plus 3. And then I have to multiply that whole thing. So that right there is the derivative of that first, that u function. Then I multiply it by v. So multiply that by 2t plus 3. Because I have u and v. So that's my v there. Now, to this I'm going to add the derivative, well, I'm going to add u times the derivative of v. So I don't want to add, I actually want to subtract negative 6 t squared plus 3t minus 1 to the negative 4. That is my u times the derivative of v. So I'm going to multiply that by just 2. And from here, I just need to, well, again, I'm going to evaluate this at t equals 0 because I want the initial acceleration. So if I've got 24 negative 1 to the negative 5 times 3 times 3 from these two terms here and here. And from this I'm going to subtract 6 negative 1 to the negative 4 times 2. See, negative 1 to the negative 5, Well, based on our discussion earlier, that's going to work out to be -1. So I'm going to have negative 24, basically, times 3 times 3 is 9, minus, once again, -1 to the -4 is just +1. So I'm going to have -6 times 2, which is just going to be me, -12 there. So -24 times 9 minus 12, I think works out to -228. Sorry, 228 meters per second squared. And that's it.